In this video, I'll talk about the molar volume and density of gases. First, let's review the ideal gas law, PV equals nRT. Pressure times volume equals moles times R, the gas constant, times temperature in Kelvin. So how do we calculate the molar volume of a gas given its temperature and pressure? Very simple. Molar volume is defined to be its volume divided by the number of moles. So it's V over N. And by looking at this equation, we know V over N is simply RT over P. Therefore, given temperature and pressure, we can easily compute the molar volume. How do we compute the density of the gases? Well, density is simply mass over volume. Mass is N, the number of moles, times molar mass. Volume is N times molar volume. This N and this N cancel. Therefore, density is equal to molar mass divided by molar volume. If we know the molar mass and the molar volume of a gas, do the division, you get the density. Or we know molar volume is equal to RT over P. We plug this in here, and density is simply pressure times molar mass divided by RT. The higher the pressure, the higher the molar mass, the higher the density. The higher the temperature, the lower the density. Again, this uppercase M is the molar mass of the gas. Let's work on some example problems. The pressure and temperature of a helium gas are 2.0 atm and 298 K. Calculate its molar volume and density. So first, molar volume is equal to RT over P. This equation comes from PV equals nRT. We just plug in the numbers, make sure that you use consistent units. So over here, this number is in liter atm per mole per Kelvin. This number is in Kelvin. This number is in atm. The result is 12 liters per mole. What about the density? Again, there are multiple ways to compute the density of a gas, but for this problem, I think it's probably easier just to use a molar mass divided by the molar volume, which is 0.33 gram per liter. Neither gram nor liter is an SI unit. I'd like to work on one practice problem. The pressure and temperature of a CO2 gas are 0.50 atm and 273 Kelvin. This is 0 degrees Celsius, and it's defined to be the standard temperature. Calculate its molar volume and density. So first, how do we calculate its molar volume? Well, we use this equation. How do we calculate the density? Again, we use molar mass divided by molar volume. But there's one more hint. Look, the pressure here is only 25% of this pressure. Therefore, maybe the volume is 4 times as big as this one, 48. However, this temperature is a bit lower than this temperature. So the molar volume probably should be a little bit smaller than 48.